There we go. Okay. Okay, that was weird. Ah. But hi, yes, hello everyone. I having trouble with my streaming software. I don't really know what's going on. But uh just making sure that I actually am live and that you guys can hear me. Looks like my mic is all working well. I was testing this earlier and just yeah, I don't know. It's annoying when YouTube decides to just nah. I keep this happened last week. I hit go live and then it just sat there spinning and I have no idea if I'm actually live or not, but I'm convinced now that I am in fact live. Yes? Yes. Sound off in the chat if you can hear me and we are in fact live. I would greatly appreciate that, but for now I'm just going to assume that yes, in fact, we are live on this lovely Tuesday morning. Hi, yes, hello everyone. How's it going? Oh, I'm excited to start sharing this with you. What we're looking at right now is a loop that I made late last week. I had a lot of fun figuring this out. It's not terribly difficult when it comes to the geometry nodes and everything. The shaders are not advanced, but unorthodox, to say the least. But I thought this would be just fun to make and show you guys how I made it because I love sharing how I do things and just making art and like figuring out how to make things look just neat, right? But also, I thought this would be a great introduction to geometry nodes for anybody who is unfamiliar with geometry nodes. So we might go a little bit slow at the very beginning just to get some of the basic concepts out of the way, talk about all of the things that you need to do in order to set up geometry nodes and how to make something simple like this. Again, the shaders are the more complex part. The geometry is super simple. And if we have extra time, because I don't know how long this shouldn't take very long to get set up. But if we have extra time, then we'll take this to the next level and maybe have multiple spheres moving around. In order to do that, we actually do have to do a lot more complicated geometry nodes. It gets really interesting really fast, but let's get going with this scene right here. So, let's pull up Blender. We are in Blender 5.2. This is a fresh scene. I've already saved it and whatnot, so we don't have to do all that, but nothing else has been touched. This is default Blender 5.2. Hold on, let me uh, close that because we don't need it anymore. All right. So, all right, we've got blank Blender file here. Got my notes all pulled up. Let's get into it. So, first thing we want to do is our contractually obligated sacrifice of the default cube. And then we're going to bring in just a plane. I always default to having a plane because we need some geometry to start our geometry nodes on. From there, just drag from the corner, create a new panel here, and then up in the top left of this panel, we're going to go down to Geometry Nodes Editor. This, by hitting either new here or in the modifiers panel, in the modifiers tab, you can hit new or add modifier, I guess, and add geometry nodes. This won't create a new geometry node graph. Uh, it will if you hit new. So let's undo that and undo that. The same thing will happen just if you hit new geometry nodes up there at the top. Again, going to go a little bit slow at the beginning because I really want to get all of my thoughts out for really the nitty gritty of how to use geometry nodes. So now with that started, we're actually going to. Do I want to get rid of the geometry input? Now, we're going to keep the geometry input, but if you hit N, if it's not already pulled up, this side panel opens, and we can go to the Group tab. There we have all of our parameters for our geometry nodes. So like either up here or over here, we can rename this. So I'm going to rename this to Space Grid because we're going to start making our grid for this effect. And then we can go down here. These are all of our group sockets. So this is all of the input over here in the side panel in our modifiers. We We have geometry, which doesn't show up in our modifiers, but we don't need that. So we're going to get rid of that, and we see our grid disappears. I'm also going to hit T and get rid of that side panel. We don't need that. Uh, so, okay, now we've got a completely empty group input node. Hit Shift A, just like you would to create anything in the 3D viewport to create new geometry. Shift A brings up all of our menus for all of the different nodes that we can create. So now we're just going to start typing in grid, and we're going to place in a grid. Oh, also, I like to turn on the magnet up here. It just snaps everything. Oops, didn't mean to hit S, but hit A, grab all, A and G to grab. Snaps everything to the grid so everything's nicely aligned. I just find that satisfying. So, anyway, now what we're going to do is take our grid, we'll plug it into the output. You always have to have an output node, otherwise, you don't see anything. Even if you have a viewer node, you can't actually see anything uh, in the 3D viewport because there's no output. So let's just replace our group output, and now you see, even though it's not connected, our viewer node does show what we've got in the 3D viewport. By the way, to to use the viewer node, this shows us our geometry and also can show different parameters. So now it's showing the UV map. Just hit Shift. I've got the order backwards in my head. Control Shift and click, left click. That will, just retarget our viewer node. So if I bring in another grid here, we can take a look at that. And since this UV map doesn't exist on this grid, it's not showing anything. So that's our viewer node. You can also switch the different domains. So if we're looking at our points on our edges, faces, all of the different element types that exist on a mesh, you can also look at instances, point clouds, I think we can look at grids. No, we can't look at grids, but we can look at layers. That's a grease pencil thing, face corners, all of the different domains that exist for us to use in geometry nodes. Or you can leave it to auto, but sometimes that doesn't necessarily show you the correct output for what you expect it to do. So it can be helpful to manually tell it, hey, even though this is some data that exists on edges, I actually want to look at the points. So it's useful for that. Anyway, we're going to get rid of our viewer. We're going to plug the grid into the output so that we actually see it. And we're actually evaluating it in the 3D viewport. Then we're going to plug in some parameters into our group input node. We're going to plug in our X and Y for both size and vertices. Then over here in this side panel, we're going to just rename these by getting rid of the X because we're going to keep our grid square. So all of these parameters are going to, well, it's going to be the same for both X and Y so that we have a square grid. Then let's adjust our defaults. So now that we actually have some parameters in here, we can switch between our sockets and you'll see all of the parameters for that socket change as we change our parameters. And we're able to change all of these defaults. So we could say, make this into a vector, and then it turns purple because that's the color of a vector. But we don't want it to be a vector. We're going to leave it as an integer. And actually, let's adjust size first. So right now, the default size is 1. Let's just change the default to 10. I don't know. That didn't do anything over here, but if we hit backspace over this parameter, it'll reset it to its default. We can also adjust this parameter over here in the side panel, which is very convenient. We then don't have to have our geometry nodes open in order to adjust this parameter. Very, very good. And just hit backspace over top of it to reset it to its default again. Then, oh, come on. There we go. Then we're going to adjust the number of vertices. The default right now is 3. So if we go to wireframe view, you can see we have 3 vertices per side. So we're going to adjust that default to 11 since our size is 10. We hit backspace. We now see that we have the number of vertices that essentially line it up with the world grid so that each face is 1 meter by 1 meter by default. Doesn't have to be. It can be whatever you want it to be. I'm just setting that kind of arbitrarily. But that is the setup for our grid node. Now, we're actually going to adjust these things. So those are the defaults. Oh, we also want these inputs. Okay, it's automatically set these to single values. That's what this rectangular socket shape means. These are single values, so it's not a grid. So it's just one value that exists for every point across the entire mesh or whatever type of geometry that we have. As opposed to like if we set it to be a field, which doesn't work for this geometry type, but then it would be a diamond that shows that each point could have a different value. So like if we take the position, which we will be using in a minute, that is a diamond. And if we take a look at the position values, we see that each point has a different value. So that's how a field functions. Each element has its own value. They can all vary independently, whereas a single value, one value for every element, but it's still stored on every element, which is important. You can use that in some cases, but regardless, let's keep going, shall we? I didn't mess with anything here. No, we're good. Okay, okay. Oh, also, yeah, we can not only change the default, but also the minimum and maximum values for all of these. So I think, yeah, our minimum and maximum are all set up just fine. All of these different defaults will be inherited, so you can't have a negative size for your grid. That just doesn't work. I mean, you can, but it doesn't really make sense. So it inherits when you plug these values directly into your group input node, it'll inherit the general defaults that you have for that socket. Anyway, now that we've got all of that set up, let's create another piece of geometry. Switch this back to shaded view for a minute. And what we need is an icosphere. This is going to be our ball that warps the space-time plane, because that's kind of the vibe that we're going for, right? A planet moving across space, and we're visualizing how it's warping space-time. That's the gist of what we're making. Anyway, down here we can adjust the number of subdivisions. We could do this procedurally in geometry nodes, but we don't really have a need to right now, so I'm just going to set it up once and forget about it for the time being. Now, how do we use this to warp this? Essentially, what we need is some reference for the location of our planet object. And while I'm thinking about that, I'm going to just rename some things in our scene because that is good practice. Keep track of what everything is. If I don't do that, then I'll end up with 20 different icospheres and they're all doing different things. And then what the heck is even going on, eh? Anyway, now that we have that, I'm also going to set shade smooth because it makes me happy. Anyway, now that we have all of that set up, we're going to take our grid. Nope, sorry. We're going to take our plane. Oh, I missed the T. There we go, planet. Not a plane, a planet. Okay, we're going to take our planet and we can just pull this into our geometry node setup, and that'll automatically create an object info node. This gives us all of the information about that object, at least as it pertains to its geometry. So we get our transform, which is, well, we get our location, rotation, and scale, which transform is just the combination of all of those in a matrix instead of its components. And then we can also use this for the geometry. So let's say we turn off. I named those backwards. That's why I'm confused. Okay. No, I didn't. I need more coffee. I didn't name the backwards. Sorry. I'm demonstrating what I want to show. So we've turned off both of our pieces of geometry here, okay? So this is our planet. No, I did name them backwards. Wow, I'm going a little bit faster than my brain actually wants to now. All right, so now we've got Hold on. Okay. Let's turn on grid. Yeah, this is supposed to be our planet. I don't know why I'm struggling with that. That's annoying. Oh, because we already had planet, it reset it to have a number to make it different. And then I renamed it again. That's what happened here. So there we go. Okay. Now this is grid. We'll get rid of that. Now everything's named correctly. How embarrassing. Say la vie. Okay. What I wanted to show you was we can turn off our planet now, select our grid, and then view the planet. Yeah, the naming got all kinds of messed up, so this node didn't know what it was talking about. So anyway, now we have two ways to see the planet essentially, but the important part here is that we're referencing this geometry inside of this geometry node setup. Perfect. Let's go ahead and plug this object into our our group input node so that we can procedurally change this in our modifiers tab. Fantastic. So what do we need that for? What we want to do is essentially take our grid and wherever this is, we want to warp the grid so that it's distorted wherever the planet is. And if we move the planet over here, then it'll be warped over there, right? The way I want to go about doing this is using, well, there are two methods. I might use the more artistic version first because it's a little bit easier. And then we could talk about like using Newtonian gravity to warp the grid. But that's, yeah, let's do the artistic one first because I think that's a little bit more approachable and just sounds like fun. Anyway, so what we need is the position. So one of my biggest questions when I first started using geometry nodes was, okay, we've got a position node. What's it the position of though? Right? Like it just says position. Is it the position of this geometry? Is it the position of this geometry? What is it? And the answer is it can be any position. It's all dependent on how it's plugged into the network. So if we say take our set position node, this will adjust the position of all of our points. Demonstrate that by using the offset here. We're just taking all of our points and offsetting them by a fixed amount in the offset. If we plug this into the position now, nothing's happening because we're taking the position and resetting it to the same position. But this is now tied to this line of geometry. And we can see that by really just making it so that it works exactly like the offset input. We can add some value to the position. Or really what I want to do is take the distance from this position to this location, and then we can use that to drive the offset, not the X, the Y. Plug that into there. There we go. Each point is now the position of each point, I should say, is now being changed based on their distance to the location of this object. And I want to be specific and say that it is this object and not the geometry. If we wanted to take it based on the closest point in that mesh, we could use a geometry proximity node, plug the geometry into there, and then use this position to get the distance. And now you can see that it's not going from the center there, it's going off of this edge, the edge of our mesh. The surface of our mesh, I should say, because it is 3D. But regardless, let's actually increase the resolution on our grid now that we're actually doing something here. 125 sounds great. Why not? And now, yeah, you can really see that it's going off of the closest surface uh, to that to every point on the grid's position. And if we get rid of the planet, Yeah, there we go. It's also manipulating the geometry on the inside. Whereas if we just use the location of the object, it's going from the very center of the object. So that's how we can start. Kind of, well, yeah, that's how we can start to manipulate our grid. But we can take this a little bit further. What I want to do is, how do we want to do this actually? Let's take this range of values and remap them to the 0, 1 range. Basically, let's normalize this, and there are a couple of ways we can do that. I actually have a custom node that does that procedurally for us. Field map range. I love this node. I highly recommend you make this for yourself. But and we'll walk through how to do that here in a hot second. But what this will do is, you see how we have, I don't know how this is going to work with YouTube's compression, but this is 5. Yeah. Oh, I guess that makes sense because it's 10 away. Whatever. We have a Z of 5 out here on the edge, at least in the middle of the edge, not at the corners here. So what we're going to do is remap all of these values so that the maximum up here way at the corner, which is a little bit above 7 on the Z, going to bring that all the way down to 1, and then everything will be, uh, yeah, everything will be in that 0 to 1 range. But how does it do it? uh, this is a really great trick that was introduced, I want to say, in Blender 5.0. I could be wrong, and it doesn't really matter. The field min max node. That, along with the field average node, lets us get the minimum and maximum values of the entire field, and then the field average gives us the average or the median. Very useful, not as applicable for this current moment. This lets us get the minimum and maximum, which is great because before we did this, we had values all over the place, all ranging from 0 up to 7 point something or other. We also have the map range node. And this is super useful because if we tell it what values our field lie between, what the range of our values are, it'll reset it to whatever other range we want. And that's super useful. It's basically a linear interpolation. We can, in fact, change it from linear to step to smooth step. There are a few other options, but I stick with linear most of the time. In order to get our field remapped to 0 to 1, basically we just take this field min max, plug the minimum into minimum, maximum into maximum, and then it'll return any value in this field in the range 0 to 1. So if we plug that into Z, there we go. We've got that in 0 to 1 range. Now, why would we want this to be in the 0 to 1 range? Well, we also have a float curve. If I could spell. Float curve node. This takes any value in the 0 to 1 range and remaps it to a custom curve. So now that we've got it all normalized, we can take this and change the shape procedurally of this fall off. So if we wanted it to be maybe like an S curve, kind of like I had in the original animation, we could just draw an S curve with this and we'd get that shape. Of course, this method means that it'll always it'll trying to think of the words. It'll change the height dynamically as we move the object. So if I grab the planet here, grab this Shift Z to not move on the Z axis, it's interesting, but it doesn't give us as much control as I'd like. So we need to pair this with a multiply node so that we can change the range of this fall off. I'd like it to have a little bit more fall off there, and then we can really tighten in this S curve and make sure that it gets a little bit wonky when you go above the 1 range here. So we'll change this to cut off at 1. kind of creates that point, which I don't love, but it is what it is. And then, actually, what we want to do before we multiply, we want to subtract. We want to subtract 1, not invert it, but subtract 1 so that our grid, instead of going from 0 to 1, it's going to go from -1 up to 0. And I should get rid of the multiply node while I'm showing this. Yeah, we're going to go from -1 up to 0 since we subtracted 1 from our range, right? Then we can multiply it so that we get steeper fall off if we want to. And that gives us a lot of artistic freedom to play around with this. Like, we can control how strong the fall off is. We can control the curvature that we've got. It's honestly really great. But I did say that we would use some Newtonian gravity to drive this. And honestly, now I'm like, well, this is actually pretty good. But it's not going to work if we have multiple spheres. So why don't we use some Newtonian physics to drive this instead? The way we're going to do that is by pulling in. Actually, real quick, I want to organize this so that we know what we've made, right? Let's take this and we'll, what do we call this? Artistic freedom. I don't know, man. Uh, I didn't really have a name for that going into this. Just this is how we would do it for full freedom and no physical constraints. But let's reset this and take our distance. And then we're going to use this along with Newton's the formula for Newtonian gravity. So that Newtonian gravity is a force. That's important to keep in mind. We're going to use this not the way it was intended. We're going to just use it to offset some geometry, but technically speaking, in its pure form, we're talking about forces here. So the force of gravity equals the gravity constant times mass of one body times mass of a second body over the square of the distance between them, the radius. That's why that's r. That's the formula for Newtonian gravity. And I want to discuss a little bit of how do we convert an equation into nodes. This is a little bit tricky, kind of like when we were discussing how position. How do we know what geometry is going to be modified by the position node? I need to stop drawing now. So we need to remember that it's going to be what's the word? Back propagated? That feels like a machine learning term, but basically we're going to read our nodes backwards. So we'll start at the node that's actually modifying the geometry and read them backwards. So we'll go from here. We're going to adjust the offset, and we're only going to adjust the z component, right? So now let's get our math in. We've got our distance, so that's our r. We're going to square it, and we could we could use the power node. This gives us a base, so whatever number we're going to square, and then the exponent. So right now it's square root because it's set to 0.5. Change that to 2, and now it's squared. This is not as no, that's not the way I want to say that. This is not that efficient, let's just say. Uh, it's easy to think about, so I'm not going to discourage you from using the power node. Because it's just straightforward. It does what it says, right? And if you don't know what exponent you need, then, use this and adjust it either dynamically or just set it to whatever weird exponent you may need. But if you just need a square root, it's much more efficient to just multiply it by itself. Yeah. Computers don't like square roots or powers all that much. They can do them obviously, but they're not that efficient. There's some weird math that you have to do that the computer has to do because the way that computers do math with bits and whatnot. So multiply it by itself, that's very easy. Anyway, this is now r squared. I don't know if I need to label this necessarily, but I'd like to keep track and make sure that it's visible what everything's doing. So this is r squared. Then, since we want this in the denumerator, we're going to divide 1 by r squared, right? Then we have our mass. Okay, for now, we're just going to multiply this by an arbitrary number. I'm going to set it to 1 because, again, it is arbitrary. We'll play with it in a minute because we don't actually have a mass right now. So use this as a variable. We can plug whatever the heck we want to into there. Uh, and I should say, because we're only using one planet right now, this equation is a force, or it expects two masses and the distance between them. We're talking about the distance between this mass and any point in space-time. Space-time doesn't have mass. So again, this is going outside of the general use case for this formula for artistic purposes. I don't know if I need to really emphasize that, but just to be clear, we're basically taking inspiration from the equation and not using it in its literal sense. Okay? Okay. So now that we have that, we're going to then introduce another variable just because, and hear me out because we will use mass, just not right now. We're going to introduce the gravity constant. So this is g. We can use this to adjust how much our position gets offset, basically. And so, I don't know, just for completion's sake, we'll say that this is 1 over r squared. Then this is m over r squared. And that's just multiplying by g. And then we can plug that into z, and wow, would you look at that. So, what's going on here? This is expected, but if you don't know what's going on, but like if you don't see it immediately, I won't blame you because that's not very intuitive, but it makes sense once you understand what's going on. So our sphere right now is at 0, 0. That's a little less important unless you know that, or sorry, that's not important unless you know that our grid is also sitting on 0, z, right? So basically, our points overlap. The point that we're measuring from, the way I should say this is the distance between our points right here at the center is 0. You can't divide by 0, so it's going to shoot off into infinity, or at least as close as it can, because we have limited number of bits, but that's why it's zooming off that way. Also, this is all positive, because why would our force be negative, basically? Like, gravity is never negative. So we're going to use g to negate it. Then it's going downward in our 3D view. This is the arbitrary artistic nature that we're playing with here, right? So that's now working correctly, except our mass is kind of big. And let me just double check I'm not getting off track. Check my notes and whatnot. Yeah, no, we're good. We're good. We're good. Okay. So yeah. So we need to basically increase the distance between our grid and our planet. Easy way to do that is take our location, change our vector math node to add here, and we're going to add some arbitrary amount on the z. Actually, it's not going to be all that arbitrary. I'm going to set it to be the radius of our sphere, which we know right now is 1. So it's going to be 1. It's still going to poke down through the grid right now, so we'll play with maybe the gravity. We could reduce the amount of gravity, reduce since it's negative. And there we go. Now it's not poking through our grid anymore. But basically, we just need to not be dividing by 0. So we're increasing the z component of the location of our sphere. Cool? Cool. With that done, that's essentially how this works. But we still have mass to play with. We can use this also as a multiplier to just, fine tune the look that we want. But of course, we have G for that. The way that I want to do this is to use the volume of the sphere to drive mass. That way we can have potentially multiple spheres that all calculate mass based on, well, this is the qualms with doing this live, right? I have ideas while I'm speaking because I'm realizing, well, that doesn't really matter. It's not that different from having a constant, right? It only matters if, again, we have multiple spheres, and then we could say, okay, this is the volume that we have for each sphere, and vary it with their independent radii, right? Their different radius uh, changes how much volume we have. And then we can multiply all of them by some constant mass so that they're all behaving correctly for their scale, but they all have the same mass variable, right? And then to make it even more realistic, we could give them all different masses too, right? Because like I think Mercury and the moon are kind of sort of about the same size, maybe. I don't know. I don't have that up in front of me, but they have very different masses. I think Mercury's a lot heavier than the moon, but they have a similar radius. So they would inevitably adjust, or they would inevitably warp space time differently, right? So uh, I'm just kind of throwing out lots of ideas of like ways that this could be manipulated. But just to have some more fun with our equations here, why don't we want the eraser to do? There we go. Why don't we get rid of our gravity equation here and bring up the equation for the volume of a sphere? So that is V equals 4 over 3 pi r cubed. So if we want to do that in geometry nodes, we're going to pull up some more math nodes. We're going to take, our radius cubed. Now we could just plug 3 in here and it would be easy. Yeah, let's do that, because otherwise we need 2 multiply nodes, and I'm feeling lazy now. So, after going on a rant about, like, yeah, just do this instead of that, and blah, 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 blah. Anyway, we're going to multiply that pi. Just type in pi, it'll replace it with 3.14, whatever, whatever. So we've got that, and then we'll multiply it by, do 4 over 3. Which again, we could have a different node doing that for us automatically, or we can just type it in. Whatever. And that is the volume of our sphere with this radius. Cool? Cool. Well, no. What am I doing? What am I doing? I forgot. No. I forgot. Nope, no, no. This is the distance from each point. I got a little carried away because it is the r in this equation. It's the distance between all of our points. This has a constant radius 1. At least for now. If we rescale this, oh, and that's, do we want to sample the scale of the object? Let's just go ahead and sample the scale of the object. Why not? Okay, so we're always going to be working with a sphere, so we're not going to worry too much about which component of this, or like trying to calculate like a bounding box or anything like that. We're going to just take our scale, just use the x and plug that in there. Now we have this, and we could adjust it any way we want to, right? So anyway, that is the volume of a sphere. And then we'll say that this is mass. So we'll have some multiplier for mass. We'll set it to 1 for now, so we can just take this and plug this into m over r squared, because that is our new m. And now we're able to adjust both gravity and mass. And you'll see they have the same effect, right? It's just that this input here, we could have, say, a mass input, and you see that defaults to a field. Fields can also nowadays be circles. So look at the line, it's a dotted line, so that also tells you it's a field. Anyway, we're going to rename this to mass. And now we have a parameter for the mass. And again, if we had multiple spheres, we'd be able to adjust that independently, whereas this would be a universal modifier. So that is Newtonian gravity warping space-time, at least for a single sphere. Again, if we have more time, I do want to get into the use case where we have multiple spheres, because we're going to have to redo all of this. Not the equations. The equations are good, but the method of sampling our sphere is going to be very different. Anyway, now what I want to do is take, well, first off, let's increase the size of our grid. You'll see that it gets a little bit, it gets lower resolution. So we'll just increase this to, say, 500 arbitrarily. 512, then it's a power of 2. Multiple of 2? Oh, it's obviously a multiple. It's a power. It's a power of 2. Anyway, then the last thing I want to do here is set shade smooth, so that we don't see all of those hard lines in there anymore. And we're going to set our material, because this grid, if we go into edit mode, is not our original geometry, which means that if we were to just set a material in the materials panel, it wouldn't apply to our evaluated geometry in geometry nodes. If we used the original grid, then it would, our original geometry, but because of the way that we're creating a new grid inside of geometry nodes, it's not going to look at the materials panel and what we set in there. So we have to manually, within geometry nodes, tell it what material to use. So let's split our viewports again, because I like to be able to play with both node groups at the same time. And we'll create a new material. We'll call this grid mat. Lowercase than a, there we go. And now in the material node, we'll set the material to grid mat. Now we'll go into material preview mode. And debating whether or not I want to store UVs, or if we just want to use the world, the world coordinates. Let's just use the world coordinates so we don't have more attributes flying around. So in order to do our texture stuff, we're going to want to create a grid. Obviously, we already have a grid in Blender, but that's not going to render. So we're going to apply a grid material to our geometry. In order to do that, we're going to take our generated. Do we want to take generated space or object space? Now we're going to go generated, because then it'll always be positive, at least so long as we don't offset our position, right? Right. So we're going to take our generated coordinates, multiply vector math, there we go, multiply them by 1 and 0 on the z, so that we get rid of all of our z values. What we're going to do is basically, well, yeah, the working through the order of operations of what to explain when, right? So we don't want our z, because we're going to basically how to explain it. How to explain it. This is the job, right? Trying to explain this succinctly. Basically, we're going to create a signed distance field and use that to create a bunch of straight lines. And if we're doing that, our z component will mess that up essentially. The signed distance field is basically just taking this field, you see it right here, our x represented in red, our y represented in green, and we're going to manipulate it so that we have both positive and negative values, and that the measure of which side of the zero it's on will determine what color we're going to paint. That's a really dumb way to explain sign distance fields, but maybe it'll make sense if we actually start walking through it. Okay, so what we're going to do is, now that we've removed the z component, we're going to scale this up. This is all normalized, so it's in the 0 to 1 range for both our x and y, and we want more space to work with. We're going to multiply that by 30, so now you see it gets really white because these are values above 1, and so your pixel can only show a 1. It can only get so red or so green before it cuts off, and that pixel's like, there is no more on to be, right? So uh oh, hello. What is the best way to start using math and geometry nodes? Great question. It's the best way to use math. Can you elaborate just a little bit? Because like my opinion would be like, figure out your equation, or just play with it. Honestly, I like to just play with things and go to town, just like multiplying, dividing, like for offsetting the position of different points. Uh, but that's just me, and my brain's a little bit. I don't know that I think through things in a very linear fashion. And let me know if there's something more specific. But I would say just play with it. Uh, and the more you play with it, the more intuition you'll develop with geometry nodes and math. Because I think of everything as a grid, or sorry, as a graph. I meant to say everything is a graph in my head. So if we're talking about like position, I see a diagonal line, right? Because we're talking about increasing as x increases, y increases. So we've got a slope of 1. Yeah. So then you multiply that by like square. You square or play in Desmos, actually. Desmos graphing calculator. That's a great way to like get an intuition for what the math does and how it manipulates the field, the graph. And then once you do that, figure out the equation, play with it in Desmos, what it would do, and play with it with the nodes. But yeah, just play with it. That's my best advice. But anyway, so we're going to get rid of our z, multiply it by 30, and then what we're going to do is modulo. There we go. Modulo. So this returns the remainder for all of our. Yeah, it divides. God, modulo. Modulo is great, but what it does is we had a range from 0 to 30, right? What it does is returns the remainder of that range divided by some amount. So it goes from 0 to 1 and then starts over, basically. Right. So now we have 30 of these squares per side. So it's a 30 by 30 grid that we've just created. Now what we can do is subtract, not color. We want vector math. We're going to subtract not 1, but a very small amount. So we're going to create a very small value. Plug that into both x and y, since we're subtracting on our vector. Wow, I can't speak. And now, can we see? Well, we can't see because we're looking at both x and y. So it's not turned black. It's just less green and red, respectively. So since we can't see it, we're going to separate our vector into the x and y component, and now we can see there's a little bit more that's black. If we increase this all of these black values are negative, and it shows black because, again, how do you show less light than none light? You can't. So it's just black. And now what we want to do is take the minimum of both our x and y. That'll show black on both axes. So now we can see the grid starting to form. And to finally really just see those hard lines, we want nice crisp lines, right? So in order to get that, we're going to take the sign. So now we're seeing just +1 and -1. And just because I don't like having random negative values for no reason, I'm going to take the maximum of this and 0. So now we just know that there's no negative values. It's all 0 or 1. And that gives us a nice, crisp grid, right? And it's all procedural. So we can take, where is it? This value, we can make them thicker or thinner. We can also take our scale, increase the size by decreasing the scale, decrease the size by increasing the scale. You know, it's inverted. So this is the number of squares that we have on the entire grid. So let's make it, we'll leave it at 30 for now, and I'm going to make this 0.05. But I kind of want a subgrid, right? Like this. Well, those lines are a little bit thick, but we'll worry about that in a hot second. Right now, what I want to do is repeat this whole process so that we get a subgrid. Now, we could group all of this and duplicate that group, but why don't we just scale this again? I'm trying to think. Let me reference my notes, make sure I'm not leading anyone astray here, because is it we just, let's see, we add, we multiply, scale, mod, subtract, scale. Okay. Yeah, okay, so after this subtraction, we're going to scale it again. So let's take a look. Again, Control Shift on a node to view it, even in the shader nodes, we can view it that way. So we're going to scale this again. So basically what we've done is when we scaled this, we're doing the same thing, but for each of our little grids. So now we can take another modulus, and we have 30 teeny tiny little grids in each of our grid cells, whatever. But we don't want 30 in each of those, so let's turn that down to something a little bit more reasonable, like 4. I think 4 looks pretty good, or at least it did in my testing. So now that we've got mod of that, we're going to take another subtract node. We're basically just taking this section and duplicating it again, right? So create a little bit more space. We're going to insert another subtract node. We're subtracting 1. We don't want to do that. We're going to take, we could take another variable and have full control over both sets of lines, but I think it's, I don't know, it's more satisfying to me to take a proportion of the original value. So we're going to take this vector, actually, and we're going to scale it to be, let's say, 0.25. So it's going to be a quarter the thickness of our first set of lines. So if we plug that into our subtract, take a look at our what did I do wrong? Oh, wait, right. Yeah, of course we don't see it because I haven't gotten to the step where we take the sign. Where did that? Oh, yeah, no, that's right. It's not vector math. Wow. Lost my train of thought for a hot second. There we go. So yeah, now that we've done all of that, we've done it twice, we can take the minimum, the sign, and then the maximum. And there we go. We have got a subgrid, but maybe 0.25 is a little bit too small. That feels rather thick comparatively. 0.75 maybe? What'd I do wrong? Hold on. Hold on. I did something Not quite right. Oh, is it because. Hold on. Interesting. Interesting. I think I'm gonna have to think through that a little bit more later. But yeah, because the grid's been scaled down, so there's no need to scale. Or well, the grid's been scaled down, so that means that by scaling the grid, we're also scaling down the amount that we're subtracting. So inherently, by scaling the grid up by 4 here, we're going to make the line a quarter of the size, if I'm thinking through that correctly. So then, no, that can't be right, because if we scale the line up by 4, it's still a quarter. It looks like the quarter of the width. I guess I could test that by plugging in 8, and can we still see? Yeah, you can still see. I'm gonna have to think through that a little bit later, because the point is that it looks good. So long as it looks good, I don't care what your math is doing, right? If it does what you want it to do, it's only best to know exactly what the math is doing if you really need that level of control. I would always encourage knowing exactly what your math is doing, but if you get the correct look at the end of the day, then that's great. You've achieved the goal. So, yeah, that's weird. I'm definitely going to have to play around with that later, but the goal here is to just have this look good, and like we can see the difference in the thickness of the grid lines. So I'm happy with that. But we're not quite done yet. So what we're going to do is invert this so that it's white. No, we don't necessarily have to invert it. It all depends, because from here what we're going to do is mix our colors, or even mix materials, because you can mix different shaders together, which is always very fun. But so yeah, it doesn't matter. It just depends on which inputs where on the mix node. So yeah, that is honestly a lot of the technical details out of the way, and the rest of this is pretty much artistic freedom. We'll go over all of it. I'm just looking over my notes, making sure I'm not missing anything. You mean complex operations like ripples, SDFs, snapping, or what you're doing right now? Okay, yeah. Like, what's the best way to start using math and geometry nodes? By the way, yeah, absolutely, absolutely. I'll answer that while I'm kind of collecting my thoughts for the next part, right? So, genuinely, play with it. I know I already said that, but like that is a lot of what I do. I enjoy, because I'm an artist and because I chose to be a technical artist, I've learned to enjoy math. So now I play with math to make good art. So I genuinely just, the more you play with things, the more intuition you'll get for it. I'm also working a job right now where I'm working with really intricate. I hesitate to say complex because I don't know if I'm actually doing that complex of stuff, but it feels really intricate and whatnot. But intricate SDFs, really complicated SDFs. Sorry for the silly question. No, 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 not a silly question at all. It's a very good question. It's just a it's only complicated because like I'm not a mathematician, so I don't know that there's a good way or a correct way or anything like that to do math. I mean, there is, but only in so long as you get the correct answer. Math is honestly a lot like art. There are so many ways to do it, and just so long as like you get the right output, or the output that you're looking for, it doesn't really matter how you get there. Like I will convert between polar and Cartesian space for certain things, whereas my wife will just use law of cosine. And two different ways of varying complexities to get to the same answer. The important part is that you get the correct answer. It doesn't matter how you got there. But yeah, so I would say play with it. Ripples, if you're talking about in geometry nodes and whatnot, learn your different noise textures because your starting input, and this is true for SDFs, math, all of the things. Uh, your noise texture or just texture in general, your grid, where you start from is the most important detail. Uh, which is why I paused at, okay, do we want to use generated or object or what have you? Because depending on what coordinate space we start in, we'll need different operations to manipulate it. And that's imperative with SDFs specifically. But yeah, what's your nickname on Instagram? I'm Gavin.js. Uh, Gavin.dotjs. I don't keep up on Instagram very much, but if you want to follow me over there, go for it. I can't promise I'll be posting anytime soon, though. Also have a Patreon, and that's not a plug for you pay me and whatnot. I do a lot of stuff on for free over there, but I'm much more active. And again, almost everything I do on Patreon is free. So if you want to hear what I'm up to and get more behind the scenes like blog posts, in-depth work throughs of how I do stuff, I post a lot of blogs explaining step by step how I do things. So I need to write that up for this actually. So thanks for the reminder there. Uh, anyway, so I know I little bit of a tangent, but getting back to this, so let's maybe take a look. I should pull up the reference for what we're going for here because I want to talk through not just okay, here's how to do XYZ, but also like okay, what's the goal? If you don't know the goal, it's a lot harder to keep in mind. Do trying to find the file on my PC because I, like an idiot, I closed it. But you know what? I can't find the original one. This is a future project I'm working through right now. That I want to talk about how to do and whatnot. And this has the multiple spheres, like I keep mentioning. So this is the goal, at least as far as the grid goes. I want this interesting like blend between the grid and kind of a spacey looking thing, and also a bunch of point lights. Well, I say point lights; they're not point lights, but a bunch of points to as stand-in for stars here, right? So that it feels like this grid is being overlaid off on top of this huge volume. It's not. Fun fact: those points are on the grid. And so maybe that's the thing that we talk about next is okay, we've got this grid, right? Now we need to blend it together with everything else. So one way to do that is to take the position node because we have position uh, in in shaders, right? And we're going to separate this. I tried several different ways to do this before realizing that we could just take the Z component, uh, take the absolute map range, map range. There we go. There we go. And we're going to go not from 0 to 1. And again, we did absolute, so it's going to go from 0 to 1. And if we were to increase this, it would just stay at 1, right? Well, the value would increase, but for our map range node, we're clamping everything, so it's going to be 0 to 1. Just important to keep in mind. Decrease that. But okay, so because of that, what we can do is adjust the minimum. So if we bring this up just a little bit, it'll clamp all of that fall off to be closer to the planet. And that's what we want. So if we do that, and then we can decrease, I think, yeah, decrease maximum. Basically, just again clamping, like really squishing in that range so that we have full grid in the middle and it peters off towards the edges. So now what we can do is mix our color using this fall off between, do we want color? Trying to think here. Nah. don't want to just take this. I mean, let me just show you what it's going to do. So we'll pick two random colors. So we've got this transition, right? So that's what we're looking for. But we need the grid in there. So let's pick a grid color. We'll just go with white right now. And that's going to be 1. No, we want that to be... This is what I'm saying with, do we want to subtract this or not? Because where it's black, it's going to use the first input. Where it's white, it'll use the second. Let's just multiply this together because we want the inside of each square to be the same color as like where we're not showing the grid, right? So if we take a look at that, that's pretty good, but I think we do want to subtract 1. There we go. So now we have white grid. Also looking at that, I'm like, man, dude, let's make this a little bit smaller. Little bit smaller. Okay. Then, yeah, I like that. Like, if we can play with this as we go. But that's starting to look good, and we're mixing our colors correctly. If we take a look here, we've got white and then blue. Cool. Then we can plug this into our base color, and we're also going to use some emission. Put those together, we'll start using our principled BSDF. And then let's take a look at our world color here. November, dude. I don't know if you've looked through my old videos, but I tried so hard to do Greasetober, but like I said Greasetober. Inktober, but with grease pencil and geometry nodes, and oof, that was difficult, but I also did my own thing. So like I should do November. I really should do November. I tend to nitpick all the details for far too long, and it's a problem. So I'll give it a try. I almost always give it a try, but I can't promise I'll do well at it. That kind of time limited challenge is really good for me because that's something I need to get better at. But man, it's difficult. Anyway, we're going to switch to rendered now. Rendered view instead of rendered preview. No, material preview and rendered. Okay, cool. But it's all black because I just turned the world color down. So we're going to turn on the sun. Rotate it. There we go. Okay. And I want the sun to not cast shadows. I just want that nice gradient on the planet and a little bit of reflection on the grid. But okay, so now if we turn this up, obviously, that's going to be a problem. So instead, we're going to use this to also drive the strength so that our grid glows just a little bit, but the rest of the space doesn't. So turn that off and back down to 0. You'll see the grid's a lot harder to see, but with it, I think that looks neat, man. Also, right back at you. Are you going to do November? Uh, it always amazes me what everybody else does for November and what people can think up in such a limited amount of time. It's always impressive because, man, my brain just doesn't go that fast most of the time. Anyway, okay, so now before we start really refining the look of the space, what I want to do is bring in our stars because I did this in a very unorthodox way. It took me a while to get to this point, right? But I started by scattering a bunch of points, which is typically what I would say to do. But it just didn't look right. So instead, what we're going to do is use a Voronoi texture. So if we take a look at this, right. Hold on. In order to use it, so Voronoi gives us a bunch of circles and the distance from basically a point in space, and well, the distance between a point in a cell and the position of that pixel so that we get this interesting cell looking texture. But in order to use this, you'll see because we're moving across the Z, it gets weirdly warped around our planet. We don't want that for our stars. We want the stars to be consistent no matter where they're at on the grid. So we need to take our multiplied generated space and plug that into our vector. This by default uses generated, by the way. Like if you do that and then unplug it, it's the same thing. So we just have to make sure that we get rid of our Z component. Control H, by the way, to hide parameters. I do that all the time. It's just a little bit cleaner. Anyway, that makes it so that it's nice and consistent. Now we just need to increase the scale significantly. What did I do? Like 2000, I think. Take a look at my notes here. Yeah, scale of 2000. I'm gonna also bring in 4D so that we can just play with the offset, right? Well, not just to play with the offset. It's also important because we got rid of our Z. Uh, Basically, all of these. No, it's 3D. Okay, I was just gonna say like we need to make sure that not all of these points lie on the plane. If we switch it to 2D, you'll see right now we have a bunch of points, a bunch of bits on the grid here where it's just gray. There's not a black dot in the middle. If we switch it to 2D, every single one of them will have a black dot. We don't want that. We want basically stars of varying sizes. So what do I mean by that? We're basically going to take the distance, because that's what this is measuring, right? And we're going to subtract a very small amount, very, very small amount, so that we get a bunch of little black dots if we take the sign. Oh, I added instead of subtracted. Whoops. There we go. Now we need to take the sign. Subtracting created a bunch of negative values. So now we have a bunch of little tiny black dots. Again, I'm going to take this and just take the maximum. Unnecessary, but bothers me to have unnecessary negative values. Then we're going to plug that into a mix node. Yeah. Another mix node for color. Something else I want to take here is it's subtle. There's a lot of subtlety in this render. I want to take the color of each of these and adjust the hue, saturation, and value. How much saturation? I'm going to be referencing my notes a lot because we're really getting out of just the pure math and into the art of it. And while I could play with the art and figure it out and make a new thing from scratch, it's going to be a lot faster to get to the end result that we want if I just reference my notes and do it the same way that I did it before. So that's why I keep going back and forth and back and forth. Anyway, we're going to take 0.1 of our saturation, so really desaturate it. If you look close, I should be using the magnifier here. If you look close, you can still see like this is green. There's a little bit of pink. There's maybe a touch of blue. Well, this is definitely blue. That's a little bit red, but it's super desaturated. Could probably have a little bit more saturation there, but essentially what this is going to be is the star color. So we're going to plug that into our into 0 on here, so that where the stars are, it inherits that color. And it's hard to see. Like I said, it's very subtle. I think it makes a difference, but it's subtle. If I increase the hue, actually, we'd be able to see it a lot better. Or hue, I mean saturation. Yeah, there we go. I hope YouTube's compression isn't ruining this, but yeah, a bunch of little colored dots. So now we'll turn that right back down so it's not as noticeable. I just like my stars to have different colors. I think it's nice. So that, and then we're going to want to mix this with our grid and space color, right? So now we have a bunch of little points. If we get close to the grid, we can see them. And we're mixing between our space and our grid and our dots, and it's all kinds of good. So now what I want to do is take... Oh, that's for the space. Okay. Yeah, now what I want to do is really get into adjusting the space color. So that's actually going to be quite a bit darker. Oops, clicked on the wrong spot there. We're going to, yeah, another mix node for this. And we're going to just use a straight noise node. Well, I say straight, we're going to mess with the scale of it, but we're going to take just normal noise node. Where are you? Yeah, because we gotta mess with the coordinates for this. So we're taking, what is it again? It's gotta be the same UV space, right? The best way to study nodes is to experiment. The way I learned, very important. Yes, dude. Oh yeah, and read the manual. Oh man, you asked about math specifically, but like if just nodes in general. Oh my gosh, read the Blender manual. It's so helpful. That's in addition to experimenting. Like you've got to experiment, otherwise you won't know the details that aren't included in the manual. Uh, this in challenge is a great opportunity when they're interested to create something cool. And yeah, yeah, exactly. Uh, yeah, learning the details, experimenting, and just creating cool stuff to discover new techniques. Like that's that's the thing. That's the way to do this, and that's the process that I really enjoy. Is just sitting down and having the time to just play with it, right? That's how this came about. I had a goal with this initial render that I shared at the beginning of the stream, and like this image that I just had brought up, and now my computer's not going to let me bring it up again. Like I had a goal here. I needed to render a planet, a more general planet, but I was like, okay, I got to actually establish how do I want to show space time, right? And just by playing with it, we got this, and now we're talking about it, and it's great. Uh, anyway, yeah, I'm just gonna copy these hex values because I really like the look that I had before, and there's no way I'm going to do this by eye and get the correct value. Anyway, so this is going to be the color of space. It's very dark if you can't tell, but this is a slightly tealish blue. Very, very dark though, and then a purple that we're going to blend between using this noise node. This noise, yeah, I've got a bunch of nodes here to adjust the space for it. So basically, we're going to take the position. This one's going to be a little bit different, so we are actually just going to use the world position. I guess I could use the object position, but, well, we're just going to use position. And we need to scale it quite a bit. So let's use our multiply. Nope. VMath. We're going to get rid of the Z. And then turn this down quite a bit. Let's actually take a look at the noise texture so that we can see what we're doing right. I want to scale this so that we're stretching it quite a bit. Yeah. And then we're going to, well, stretch it the other way, but by a different amount. How does that look? I think that, well, our scale's a little bit big. Again, I'm realizing now there are so many ways that you could do this that like some of this, what I'm doing right now is a little bit redundant depending on how you want to go about it. But like in my notes here, I've added an add node so that we could adjust on the Z. Since we're not using the Z, we can use it basically like a W, but really we could just switch this to 4D and then adjust the W and it'd be the same thing. Uh, so again, just play around with it, and sometimes you realize things you've done are somewhat redundant, but it's whatever. It's part of the learning process, right? Anyway, so basically all I want is this grayscale to just switch between these two colors. They're both white, dark. Yeah, they disappear. In a minute, we're gonna switch to cycles because cycles, just, there are things about it that I like the look of that we just can't get in Eevee, even with the newer Eevee update, right? So trying to think, should we just switch to cycles now? I don't want to do that immediately because I don't know how my computer will do with cycles and streaming. I guess to start with, let's adjust some of the cycles settings, or the output settings, I should say. Now I gotta switch to cycles to adjust the settings that I want because I don't need in viewport it to do 1024 samples. We're just gonna do like 4 and it's gonna look like crap, but we don't need that many samples. And then I'll put that to something like, I usually render with 32. I don't know if that's good or not, but it looks nice to me. That's for darn sure. Anyway, going back to this, we're going to adjust the noise here. What I want to do is add in a vector rotate just to give us a little bit more control over this. Since we scaled it on our axes that way, now we're just going to add a jaunty angle by doing that at the position so we can actually see the angle, right? There we go. So just whatever looks good. Doesn't really much matter. The important part is that we get this color out of here. So now we can replace our blue with that. Now we can see our grid on this overly dark space, but it's okay. We'll brighten it up in a hot second. Then that's getting mixed into here, and we need to plug our stars into the color of our BSDF. And that should be good. Now, because we have different values in our space color, what I want to do is take this overall color, right? We're going to separate the color so that we get our HSV. We're going to take the value of this color and use that to drive the strength of our emission. So our stars and our grid have a high value, so they will be bright, and our space has a lower value, but that noise that we've created with the color will also give off like a little bit of emission. So it's not just a dark, dark background, right? So that's the idea there. Again, probably not the best way to go about this, but it's my way of going about this. And we can go ahead and add in a multiplier, multiply add, so that we have some control over this. Don't want the vector version of that. We want math, just math. There we go. So now we've got a multiplier. To really crank up the brightness of the stars in the grid, I'm going to set that to 4 to just like really brighten it up. And we're going to add 1 so that our whole grid has quite a bit of value here. By grid, I mean all of the space, what I keep referring to as space. So now if we take a look at the rendered view, it's starting to look okay. If we add in a camera, and let me know if the stream cuts out, because we're playing around with cycles now. And I don't know if my GPU will like this, but we're going to take the camera, lock our view so that we can adjust it manually like this, and just play around with the view here so that we can see what all's going on. Oh, and there's one more thing that really sells Like I wanted not just the grid, not just the colors of space and whatnot. I also really wanted to add this neat like water effect, as if like the planet's sitting on the surface of a still lake. So in order to do that, we need to introduce some normal values, right? Everything is okay. Thank you. I appreciate it. uh, but okay, so we need to play with the normals of the surface, right? So again, we're just going to add a noise texture and we're going to bring in a bump node. This will take our noise. Let's get out of uh, rendered view. There we go. Material preview. We're going to take some noise. We're going to turn it into a normal map so that it's adjusting how light reflects off of the surface, right? And we're going to plug that directly into our normal. That will create, we'll see it in this view. Perhaps not. Oh, we need to increase the distance. We're going to increase it or set it to 0.05 so that we can see it a little bit better. Actually, just want to see. Let's get rid of the emission for now. I really want to see how the light is bouncing off of the surface here. Yeah, you can kind of see how it's going in and out there. If we get rid of the normal, that should go away and it'll smooth out. Yeah, there we go. So, okay, that's helping, but it's not quite there yet. We also want to adjust the roughness. So right now the roughness is quite high, and that would help us see the normals if I turn down the roughness. So yeah, we can see, especially as we look out across here, all those little ripple looking guys. Again, we're talking about very subtle details. So if it's not immediately obvious, uh, it's definitely the computer's fault, not mine. But okay, yeah, you can see it looks a lot smoother now, and then plug it back in. We get a little bit of distortion, especially around that warping. So we've got that now. Let's add in a little bit of noise for our roughness. Actually, let me make sure. Yeah, okay. We've got some more work to do with the bump, but for now it's good enough. I'm going to increase the scale though, because there we go. Now we can really see it. Everything else should look good enough. Yeah, I think it's fine with all of the defaults, honestly. Maybe don't need to normalize that. If we get some negative, yeah, that's interesting. Okay. Okay. So that, and then we'll use one more noise texture to really drive the roughness, the roughness of the surface. Just helps break up some of those reflections so that it's it's not a perfectly like words are failing me. It's not a perfectly like crystal smooth clear surface. We want a little bit of distortion. Again, like it's a lake. Like we're looking at the reflection of the stars on the lake, but the stars are underneath the lake and the grid, and it's very ephemeral. Uh, anyway, so we're going to take this noise texture and we're going to map the range of it so that our factor goes from 0 to 1. No. We're going to output 0.05 to 0.15. That's the range of roughness that we want. Just a touch of roughness, and, not equal roughness everywhere. So that should really help to break up those reflections. And if we go back into our render view, there we go. Like, look at that. Look at that reflection. That's so good, and only with 4 samples. Oh, it's so good. But we've lost our stars. Oh, right. Right. I forgot I unplugged the strength of the emission. So now we're getting the color in our space. We're getting the stars. There's quite a bit of star. We're not quite done yet, but I want to just hit render to see how this looks in the like get an idea of it. If I were smart, I'd just render a little section, but I want to see the whole image. I'm greedy. We're just going to wait for a hot second for this to render and we're good there. So, okay. Okay, the stars are a bit much. Stars are a bit much. Should should I turn that down some? Let's see. Maybe. Let me think on it for a hot second here. Or no, if I switch that to 4D, does that? Yeah, that looks better. Okay, hold on. There we go. Okay, let's switch to slot 2 so that we can do a comparison. This should have fewer stars than we just had a second ago. Because we switched to 40. Another way to do that would be to reduce the scale of the texture, but then I'd have to adjust the radius, and it's just easier to go with 40. Okay, yeah, that's looking pretty good. I like that. But there are a few more things to do. Well, and maybe most notably, let's select our planet, give it a new material, and actually what I'm going to do is open up Asset Browser because I have uh, assets that I bought from Ducky 3D. Ducky's great. Uh, I don't have it all set up properly because I bought it several versions of Blender ago and I haven't bothered to set it up to like work all nice the way that he made it and whatnot. But uh, I have this paper material that just it looks nice for a nice blank canvas. That's kind of the vibe that I wanted for this is that we're just looking at a blank canvas, blank planet, uh, for as kind of like a teaser towards a larger project that I'm working on. But a blank planet to just play around with. So now we've got the paper shader in there. That's nicer than just a gray orb. And it also reminds me, I don't want this color to be white. It's going to look much more like the paper here. So I actually have a slightly orange tone that I want to use instead of the white. And again, it's subtle, but it's nice. It feels right in a way that just pure white doesn't. So let's do another comparison render here. Slot 3. And then I don't think I did last time, but flip through these just to get the full comparison, right? Give it a hot second. There we go. It's rendering a lot faster than I expected it to. I guess last night I was playing around with the earth that I showed a few minutes ago, and there are some large textures in there, so that was taking a while to render. This one's going much faster, though. Now the video is flickering a bit. Okay, is it good now? Because it might have been because I rendered. If it's still going, now that we're not rendering, let me know if let me know. I appreciate the feedback a lot, so thank you. Anyway, so that's before we messed with the Voronoi, fixed the stars so that it's less dense, and now, yeah, we changed that color. You can really see the difference in that color. Yeah, and the sphere, like that's good. I want to change the camera placement a little bit so that so that the sphere isn't like literally dipping into the grid. Let me make sure I don't see any flickering anymore. Or at least on my end, I don't see any flickering. If there is flickering, I want to correct it. I'm going to keep going, assuming that the flickering was just while I was rendering. So let me know if it's still flickering, because then I'll take a hot minute. Uh, then I'll take a hot minute and try and fix things. And maybe stop rendering while doing this live. We'll just switch to Eevee to get kind of the core principles out of the way, right? Okay, so anyway, I think that's almost everything for the overall look that I wanted to do. It's just a little bit. Sometimes it flashes. It started a couple of minutes ago. Okay, okay. I'll darn because like if I render it, the payoff it really is in the render, and I have a feeling that it's because I started rendering frames. I don't know. Well, I'll keep. Let me know if it continues. Thank you for the feedback. I really appreciate it. Uh, but okay. To just keep going for a minute, let me do the last couple things because that should be everything with the material. Should be everything with the material. Yeah, we've got color, we've got the strength of the emission, we've got the roughness, we've got the bump, we've got everything but animation. There are a few ways that this needs modified in order to animate, but I'm not going to get into that at the moment. We've got the stars and their color, grid. Yeah, okay. So the last couple things to really sell the effect. We're going to play with the camera, which again, I'm going to adjust this. Maybe I'll switch to material preview because it might also be the rendering in the viewport. That's the problem. Part of the problem, at least. Anyway, I want to adjust that so that we're looking down a little bit more. Zoom in, why not? I just don't want the planet literally clip into the. I don't want the surface to cut it off, right? So I also don't want to be looking just straight down. So we gotta kind of thread that needle. But I think this is an okay angle. I think that looks nice. Okay. And now what we're going to do is with our camera selected, we're going to go into depth of field. And this is always fun to play with. I find it best to select an object to focus on. So we're going to set the planet as the object and then decrease the f-stops. I think a little bit below 1, you start to get this bokeh effect with the stars in the foreground and the background. Um, and I really want to show you, but we're gonna hold off on that for a second. It's still flickering. Ugh. Okay. Weird. Hold on. Let me play with the settings, the stream settings, see if I can fix that. Do. Actually, let me see if I can witness some some of this flickering in the preview here. Hopefully I can figure this out. I don't want this to look bad, you know? Also don't want to waste a ton of time, but if it's not looking good, then what the heck's the point, right? If you can't see what I'm doing, then what are we even doing here? Why are we flickering? Especially when you're doing something with textures. Oh, that makes sense. And okay. Okay, well, we're done with the textures. So that's good. That gives me pause for future streams where I was going to play with textures more, but yeah, that's fine. Deal with that later, I suppose. Um, I think. Oh, my camera's. Oh, I see. Okay. If it's just my camera flickering, honestly, I would so much rather you be able to see like what's going on in Blender. So I could just turn off my camera and it'll be fine, in my opinion, at least. If you'd rather me can like try and figure out how to. Yeah, okay, it's when the viewports update. Okay. Oh, that's interesting. This is interesting. Okay. Technical problems to work out. But I think the short-term solution would be to just turn off my camera and you don't get a face cam anymore. If that sounds all right. So long as you can see Blender, like that's the more important. That's so much more important than looking at my ugly mug. So, I think that'll be. I think that'll be the solution for now. I'm glad I was able to see the preview of the stream, be able to see what was going on. Like I was able to like go back in time in the stream and find some of the flickering. Anyway, what am I looking for here? This is what I'm looking for. Desktop screen capture. That should do it. Um, Now I've disappeared. I'm a ghost. I'm just a voice in the box. I don't know. I don't know what I'm saying at this point. Anyway, uh, let me know if that's an okay solution, and I'm just going to keep going for the time being. So what we're going to do next, and God, I'm so glad that it's not like the render, because I really want to show more renders. Like if that's the case, what we're going to do is just do another render, because that doesn't seem to be causing flickering. Because I want to show the bokeh effect with the depth of field on the camera, because it's cool, it's fun. It kind of creates the feeling that we're looking at miniatures instead of like it's like when people take the videos of like cities and then speed up the footage and like do a tilt shift uh blur effect to make it look like it's a bunch of little tiny toy cars and toy people just rapidly moving around a city. It gives that vibe to me. I don't take it quite to that extreme, but I love depth of field for adding just a little bit. Just it makes it feel cozy. Is that the right word? I don't know. But yeah, the depth of field unfortunately also adds to the render time. Doesn't look like it's causing any flickering in the main view, so that's good. Good, good, good. Any minute now, it should. Yeah, we're 15. I should have gone with maybe 16 samples for the stream, because then it'll go a little bit faster. Yeah, because we're up to a minute and a half on this frame. Depth of field really adds to it. So okay, I'll get rid of that for the rest of it until we get to the end, because that's for the amount of bokeh that we get in this render, at least it's not really adding that much. So I'll get rid of it for a moment, because we don't need to spend that much time rendering. So get rid of the depth of field, and then what we're going to do, so now, and I guess now that we've rendered that, the last thing I want to do before like just starting to nitpick and tweak a few settings, uh because this is not exactly the look that I was going, like, I don't know, it's, if we look at that render, I think this version needs a little bit of work, but regardless, the last step that I really want to do is to go into compositing, and usually I just play with the panels on my screen, but for this we're just going to go to the compositing tab, hit new, so that we can take a look at the image that we just rendered. And this is so simple. It's the smallest thing. We're just going to add some fog glow. That's all. You can play around with this, adjust it and whatnot, but I find that setting this to like 0.2, so that it brightens up uh the planet there just like a touch, it adds so much. Doesn't seem to be adding on right now. There's something going on that I gotta, like, what's the difference between my notes version and the other version? Like, take a look at compositing. Okay. I had it set to 0.2, maybe 0.1. Yeah, that's a little bit more. It brightens this up. Brightens everything up just a little bit. Like, hmm. Let me. Nope, that's not what I wanted. Go away, Opera. I don't need you. I want to pull up the another reference, not the Earth and Moon, because there are a lot of differences between this and that. I need a different. I need the actual reference that like I put in the thumbnail for the stream. Where did that go? Yeah, I think this was yeah. Yeah, I gotta adjust some of the colors. Like this is weirdly purple. Even though I put in the same, I think it's because the noise is different. So like there's purple in the middle here in the reference, whereas the horizon is more green. Might also be that I haven't set the world uh color correctly. So let's go back to layout so that we can see everything. And what is the world color over here? In my notes. Oh yeah, that's so much more blue than what I had. I made this purple, and it looks weird. So okay, let's adjust that. I'd also like to adjust the grid so that it's the noise is different for our color mixing. Just increase the scale so that we get where. Oh yeah, no, I don't know if this is coming through on the stream, but this is much more green around the edges with some more purple in the middle. And ooh, it looks better. So now I'm going to run the risk of rendering one more time. And do I want to do that, or do I want to maybe do one last detail? I don't know. I'm debating whether or not I want to add the circle in at the bottom, because like this fall off is not the same as what we've done. This was more of the artistic with the curves as opposed to the gravity. This is fine. This is fine. Okay. Cool, cool, cool. I'm glad it's coming through. Uh or sorry, I lost my train of thought. You're saying don't need to add the circle. There's enough of a delay that I'm just talking and getting lost in my train of thought, but yeah, I think this looks good. So why don't we go ahead and render this? It's gonna take a hot second because, or no, I turned off I turned off depth of field, which I think adds quite a bit. Oh, it's interesting too. Yeah, I want to bring the depth of field back in. This is also a lower resolution than what I rendered initially. Uh, where is it? This is actually 256 by 1440 as opposed to 1920 by 1080. So like this, we can zoom in quite a bit. Like that's real scale there. Anyway, so like, yeah, there's some pixelation around the edges here. But what I want to actually do here is take the sun and rotate it on the Z, because there we go. It's much better when we see that gradient. Actually, if that's maybe a touch too much. Like the light was we were looking directly in line with the light, and it made the planet look flat. And that's not what I want. This looks much more dynamic. And speaking of looking dynamic, let's just scoot this off center. I think in the original I had it over here. If we're going for making it look like the original, if it's off center, it makes the eye lets the eye wander a little bit. But if we're going to do that, then we've got to rotate it a little bit. Now I'm really just nitpicking and trying to make an interesting composition, right? But I mean, that's what it's all about. So done that. I'm going to, before I forget, turn depth of field back on, which will give us more wait time for that render, but I think it's worth it. Uh, then we'll have the bokeh effect. We'll have the compositing of a little bit of glow. We've got all of the lines, the stars. That should be everything. I've corrected the color. I'm just going through the checklist. So that should be everything. There are so many little details that I'm just like, the geometry nodes were honestly super fast. It's all of the little details of actually trying to render it and get everything to look correct that I'm just like, yeah, gotta just finagle it. Was there anything else I was going to adjust? I think that was it. I think that was it. Let's just go ahead and render. I forgot to switch slots as I was doing it, but that's fine. I don't know. Is that composition? Oh, I was going to reduce the amount of grid that we see, but what did I forget? That rendered way too fast. I don't think I forgot anything. The glow on the grids. Yeah, I should say, okay, we're basically done now. I'm just really nitpicking details. Like, I'd like to bring the grid in a little bit more, work on the composition some more, maybe decrease the amount of strength on the emission of the lines. But, like, this is that ethereal, ephemeral space water look that I was looking for. Uh, so yeah, and now I don't know if it's worth getting into like adjusting the geometry nodes to have multiple spheres and animating all of this because these geometry nodes were simple. Getting multiple spheres to work will take a little bit of mental gymnastics to work through. Okay, how does geometry nodes process different data types? We have to adjust, like, turn our geometry into instances to and back to points to then reference and sample all of our different spheres as if it's a field, and it's a whole rigmarole. But so maybe I'll save that for next time because it's interesting and it's worthwhile, but it is not going to go fast. Yep, the field is on. Okay. So I'm going to just play with this for a hot minute, but that is essentially what we're looking for. Let's reduce this, yeah. Yeah, I want to reduce that, and then by reducing the Z range, we'll bring it in. No, it's the minimum that I want to adjust. Bring the minimum up, I think 0.15. There we go. Yeah, I like that a little bit closer to the sphere. Turn down that brightness. I also want to make it look a little bit better. I don't want that square. What am I doing? 256 by 1440. Since it's rendering relatively quickly anyway, uh, I'm just going to increase the resolution so that looks a little bit nicer when we uh, like the lines are a little bit crisper and all of that. Like that looks pretty good. The composition needs work. Composition needs work. So yeah, like it doesn't need to be up off to the side. Great. Rule of thirds and all that. Roughly. I know there's a way to turn on guides for that, but I'm just going by eye. It doesn't need to be off center on the vertical. I think that'd be a better composition. So let's switch slots so that we can compare, right? Yeah, I'm so happy that that's rendering faster now. I don't know why it was taking so much time before. Might have been because I think that was around the time I was looking at uh, the flickering for the stream. So, like me previewing the stream while also rendering. I don't know. Maybe I'm misremembering that, but whatever. I like that composition better. Like that's weird. That's weird, man. That's a lot better. There's a lot of open space. Like this, I feel like it's dynamic if it were moving, but maybe I'll just recenter it. Or even adjust the rotation of the camera. Again, it gotta, like, the closer this is to horizontal, the more interesting I feel the scene is. That's maybe what's bothering me. Like that's much more interesting to me. So, nope, not 6. I want 5. Yeah, that feels interesting and dynamic. Maybe went a little bit too extreme with that angle, but like I think that's cool. Now I'm just debating how fast can I just speed run. If we're just having fun with it, I could probably speed run doing multiple spheres. Screw it, I've got a little bit of time. Let's do it. All right. So, uh let's go back into our grid. Actually, no. Okay. So, we're not going to step through this quite as much, like step by step, really getting into the nitty-gritty of how geometry nodes works, like I did at the very beginning, because that was me trying really hard to explain geometry nodes. So now we're going to go a little bit higher level and just kind of explain a little bit more advanced geometry nodes, right? So we've got an object here. We're referencing that in our grid. That's the shader. We're referencing this object in the grid, right? But what if we want multiple objects? So we're going to duplicate this and move it over, Shift Z to move it over on, not the Z. How do we reference multiple objects to do this same transformation? The answer is with a collection. So we're going to create a new collection. We're going to call this planets, and then move both of our planets into this collection. So now on our grid, we're going to replace the object info node with a collection info node. This, for completeness, we're going to plug our collection in there. We're going to set it to planets. And now we have all of our planets as instances inside of our grid object. Also going to get rid of our volume equation because we don't need that. Label this volume. Label this gravity. Okay, cool. So, oh, wait. Okay, remember what I said about using the collection, but actually what we want to do is not reference that directly in our grid. We want to create a new piece of geometry and call it planet points. Now what we want is our info, our collection. We're going to create a new set of geometry nodes, collection info. We're going to plug that collection in. We do not need geometry here. We're going to have output our instances. There we go. We see our planets. Okay, but we don't want just to output our instances, because basically what we've done is converted our individual objects to a collection of instances. Just trying to bring up my notes so that I don't get this wrong. So what we want is a field, or really just we want to convert these into points so that we're able to reference the position and also the scale of each of our planets. So since we have these planets, we're going to scale this down just to show that they are independent and we're able to see not only where they're at, but what the scale is. Now we're going to turn that back on. And we're going to realize our instances because right now they're independent. We need to separate our children so that we have two different instances correctly placed. And then what we want to do is figure out what the scale is of each of these. Uh, we can't do it the same way we did before. We can't use an object info node because we're not using an object anymore. We're now using individual meshes within one object. So we need to figure out, we need to treat these basically as separate mesh islands. So let's get a mesh island node. And man, how to explain this because it's a little bit wonky. Basically what I want to find at the moment because well, what I want to find is the position and the scale. I'm just looking over my notes because it's not very intuitive. Like I can show you my notes. This is not very intuitive, so I'm trying to read my own nodes because I didn't actually take notes on these nodes because I didn't fully anticipate showing this, but I thought it'd be fun to just go for it, right? So, okay. And we're going to modify this slightly because the way that I did this is not the same as how I would do it in this scene. So, okay, what we're going to do is take, we want to convert these instances into a mesh and then the mesh into a point because we want a point at the center of each of these and we want to store named values or named attributes on both of these meshes, well, the individual points to store our scale and our position, right? I keep saying that we need the scale and position, but it really is important. How do we get that from instances? We've realized them, so now what we want to do is look at each of these mesh islands independently. We've got a field here, so we're going to we need to get the scale. The scale is kind of the difficult part. We can't just convert them into a bounding box because the bounding box of instances won't give us like the size, like that just won't quite work. Instead, the way that I did this was to use sample index nodes to take the instance here, and what I want to do is I guess basically we're going to average the position of all of the points for each of our island mesh islands. So we're going to take the mesh island, we're going to use the field average node, take the position, and we're going to average out our position. So that is the position of each of our mesh islands. So if we take that, we'll see this is at 0. That's the average of this sphere because all of the points added up together, averaged out, what have you. It's right there at the origin. This one is in the positive x and the negative y, so it looks red. So we've got our independent positions of each of our mesh islands. That's important because in order to find scale, where you need to basically find the radius of this sphere. And again, we can't use the object info node to get the scale. So we're going to measure the distance between the average, so the centroid of each mesh island, and any given points on the surface. So why don't we just take no, not the field average. We need minimum maximum of the index of our points. So take the integer, we're going to get the minimum index, which would be 0 on our first one and I have no idea on the next one, but we just want 1 point is kind of the point here. We want to use this to find the position with our sample index node. So we're going to take for each mesh island, the island index, we want to find the minimum index and plug that in to find the position of that index, the minimum here. So let me see if I can turn on attribute text here just to show this is giving us a minimum index of 0 and a minimum index of 642, right? So then we will, since we have that index, we can sample specifically that point in each of these meshes to find the position, and then we can take the distance. There are other ways to do distance that are slightly more efficient, but whatever, we're just going to take the distance between, we don't want this position, we want the average position and the position at specifically that point. That will give us now the scale of both of these planets. So this is still set to a scale of 1. This is set to a scale of 0.455574. And we can see that if we select this planet and go down here, we have a scale of 0.55574. So this is working correctly, right? Now we just need to store that as a named attribute, but we don't need all of this extra geometry. So what we're going to do is basically just delete a bunch of information. I think before we do that, just to make sure our order of operations are correct, we're going to store a named attribute. We're going to store, well, the position will be inherent, so we just need to store the scale. So a float, we're going to call this scale, plug our distance in there. Now we've got that saved on all of those. Now we're going to delete some of our geometry. What geometry are we going to delete? Every point other than this point, the one that has the important information on it. Well, really, it could be anything but 1 point. I only want 1 point per mesh. So let's so it's easy because we've already found a specific index here that we know is unique to each of our mesh islands, right? So we're going to delete everything that doesn't have an index equal to that point. So we'll plug that into here and delete our geometry. So now we know that we've got index 0 down here and index, what was it, 642 or something over here. Our positions are wrong though, so let's just set our position to, we might need a capture attribute. Now this should work. We'll take the field average and set position. Well, that did not work. So, oh yeah, because this is, since we're using this line of geometry here, we've already deleted our points. So the field average is the position of that point that remains. So that doesn't work. We need to, again, maintain our order of operations. So we're going to do this before deleting all of our geometry. Now use it to set our position to the average, while there still is an average to set to. And then we can delete all of our geometry. And now we have a single point for each of our planets. Cool, great, fantastic. Now what we can do, after I clean this up just a little bit, because it's going to bother me if I don't. Yeah, that looks all right enough. We've got both of our points. Cool. Yeah, and you can see them a little bit, maybe a little bit better if I highlight them. Doesn't matter. Anyway, we've got both of our points stored in a new piece of geometry. So now what we can do is go back to our grid, right? And we need to do we want repeats or for each element. I think we need repeat because we're going to use two different pieces of geometry. So basically what we're going to do is all of this for each of the points in our planet points geometry. So going back to our grid, also don't forget to save your projects because I'm realizing I haven't done that at all. And it's been like 2 hours or however long, I have no idea. Anyway, we don't need our collection info node anymore. We're good there. But now we do need our object info node. We're going to use this, but instead of using our planet object or collection, let's get rid of our collection. We don't need that. Instead, instead of using our planet, we're going to use our planet points object, right? And right now it's doing the same thing, but it's just using the first it's only doing it for one of our points. We needed to do this whole operation multiple times. So we have this repeat node here. We're going to plug our geometry, our points, into our repeat node. And yes, I did plug that into a new geometry socket because we are going to, because we need to set the position of our grid. Oops. Now that was a mistake. We're going to set the position of our grid, sampling our scale and position of the planet point. The planet point of that iteration. This is getting a little out of hand, so we're just going to move things around some. Move this over. This is going to be inside of our loop, I'm pretty sure. Okay, so our loop should look something like this. Plug this into here, that into there. Did I reorganize that correctly? I think so. Okay, cool. We just need to tell it how many iterations to do. So we're going to use this geometry, read the number of points that we have, and that's the number of iterations that we're going to do. So now we just need to get the location, the position, and the scale of each of our points. So we need two sample index nodes. We're going to plug the iteration into index so that we're basically going to use the iteration as the index to loop through each of our points. And we need to set this to vector. This is going to be our position. For each of our points, we will replace the position of this object with the position of each of our points. And you can already see that we're doing it twice now, which is great, right? Now we just need the scale, and we'll get a named attribute. I mistyped that, didn't realize. Oops. But yeah, we'll plug our scale into there. Let me correct that mistake over here in our planet points. We're going to go back to our grid, and then this, at the beginning of the stream, I said, hey, we've got mass, or really we've got a radius here. Yeah, we were taking the scale of our object and using that in our volume formula. So we're going to get rid of this separate vector node and plug our scale into the base there. So now you can see if we go to side view, maybe this side view, there's still a little bit of a bulge, but it's not that drastic because that planet is a lot smaller. If we increase this, you'll see that it dynamically changes, right? And this is where we need to start fine-tuning some of our variables because that's just not quite working. Oh, and also, I forgot, we also offset the position by 1 because that was the radius here. We don't want our points floating right on the plane because then we're dividing by 0. So we need to remember to combine our vector take the scale, make it the radius, to then add to that so that now we're using the proper radius here, whereas before it was sitting up here at 1, just like it is for this one. So now these are all working correctly. And again, we can, use some of these other values like gravity. I think gravity is really the only value here that is a constant. Like that's a parameter that we can play with. Set that to -1 for a moment, and then we'll bring in an input node. We had mass as an input before. Don't think we're using that anymore. Hold on. Where are we using mass? Oh, we are using mass. Oh, yes, we can adjust mass. That's a global parameter right now. You know what we can do? Now, I'll finish the loop with gravity first. We can make it so that each planet has its own mass, but right now we're just going to plug this in here. We're going to just call that G. It's set to -1 now, and we have a global parameter for the for how much we warp the grid for all of our planets. Mass, we're actually going to go to each of our planets, create a new geometry node, new, call it set mass. All we're going to do is add a stored named attribute, call it mass, plug this in. Or actually, we need to rename it in panel here and then set the default to 1. I don't want a negative. We're never going to have a negative. We could maybe do some interesting effects if we did have it set to negative, but I don't want that today. So we're going to store a mass and set that to 1. Then if we go back to our grid, we could either have in our side panel here, we could set this to use mass. No, because that doesn't exist on this geometry. Now we have to use a named attribute. Okay. So we'll replace that with a named attribute, mass, plug that into there. And why aren't you working? Time for some live troubleshooting. Okay. Oh, why aren't you working? Because this should... Hold on. For our instances, do we have mass? 1 and 1. Okay, cool. So that's just not 0. If I reduce that on this one, do we see... Yeah, 0.892. Okay. Okay, it is working, but we need to carry it over from our instances to our mesh, because if we take a look over here... No, that also works. Oh! Oh, no, 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 no. Everything's working fine. The problem is we need another sample index. It's the same process as all of this, so that's just me forgetting how all of this works together, and also doing this on the fly, because again, I didn't anticipate this as I should have. But it's fine. We'll replace this mass. There we go. Okay, beautiful. So now we can put all of our nodes away, take a look at our planet, and adjust each of these and their masses individually, as well as on our grid, the global gravity force. So there we go. Now we can really play with how strong each of these planets warp space-time. And I think I just duplicated this object. So if we go back to rendered view, yep, it has the correct material. It's even warping because we used the position. Our grid is being manipulated correctly. Everything's working well. Let's go out of rendered preview and just back to material. It's a little bit much. why don't we turn our gravity up or down? Whatever. Gravity down some. We'll turn the mass of this planet up some. Yeah, just play with it, play with it. But now we can grab this and move around, and it works correctly. And then we could animate everything. But that is definitely more than I have time for today. So let's just make a nice composition. When did I move the camera? Oh well, doesn't much matter. It's an interesting perspective, but not one I'm interested in exploring today. So let's go make sure we stay at 0 on the Z. Where do I want to put you? That's going to be interesting. Okay. Okay. Let's take a look at the image preview here. Go to a new slot, and I want to hit render and just see how it looks with 2 planets. I think that looks pretty neat. It's still rendering, but like, yeah, no, that works. And like I said, it's not as straightforward to just like, plug another set of like to just add more planets and whatnot. We had to step through creating specific geometry to read the instance collection, to then create each of our mesh islands, to do the whole rigmarole to get this. And I'm pretty happy with that. The composition needs a little bit more work, but I'm pretty happy with that for, doing all of this live and sharing it with you guys. So thank you so much for hanging out. Let me know if you have any questions. I'll hang out for a few more minutes, but I think that's kind of the end of this tutorial and this stream, and really making progress on all of this. But yeah, just wanted to share some art that I've been working on, share some of the progress or process. I mean, uh, how I've been going about creating this interesting ethereal space look. It's been really fun to play with. I did show earlier. I've been working on rendering Earth and the Moon and all of that. That's the full size here. So, uh, like, there's a lot that can be done with this. Actually, I want to play with it just a little bit more because the size of the grid, uh, is bothering me. But thank you. Also, I just realized you said this is fire earlier. I thought you said this is fine. This is fire, and it's so cool. And thank you. I appreciate it so much. I've had a lot of fun developing this and playing around. And I don't know. Maybe my brain's just a little bit broken, but I think that overall this is pretty simple. Like, it's not as complicated as it could be. So, uh, like, I don't know if anybody else would call this simple, but I'm having a good time playing around making this sort of art. Let's do one more comparison. Also, hello, Andy. How's it going? Uh, this is the tail end of the stream. Sorry, you're tuning in right before I'm getting ready to end it, but go back and watch because I've had a lot of fun sharing this process. And hopefully, I should have fixed the composition. I want to bring the whole thing down. I need to move the camera up. Shoot. I could have done that before rendering. Oh well. That's fine. I want to see how this turns out and compare the size of the grid lines. Oh yeah, and also if you wanted to, you could use the same method for creating the lines. That SDF method of just, subdividing the grid. Uh, use the same method to create a bunch of dots. but I don't think dots look as great with all of the stars. It starts to look a little bit messy. There's not much like shape contrast, uh, and I think it would look good if you got rid of the stars, but then it would just look kind of empty. So it is what it is. But yeah, just having fun waiting for this to render. It's now taking a long time again. I don't know. Maybe it's because I changed the size of the grid and like maybe overwrote some cache. Like it only needed to do once and then it started going faster because it was all that was in memory. But now I've adjusted everything and it's going, what the heck, man? uh, and I would love to throw some textures onto these to show the Earth and the Moon and whatnot. But like the whole process, I can show that real quick while we're waiting for this to finish rendering. So these are my notes that I've been working off of, but it's actually for the other project where uh, I'm working with the Earth and the Moon and whatnot. So like I have materials on these now, and now Blender's upset with me. There we go. Just to show you the Earth, right? Again, I have nothing labeled correctly, but these are all of the textures that we're playing with here. Lots of different pieces of the Earth. The clouds suck. I'm working on developing the clouds before I really show off how this works, but the texture I have for clouds, I think it's this one, looks much better. But anyway, yeah, that's just for the Earth. The Moon's a lot simpler. It's one texture, very easy. Some math to manipulate texture coordinates. I used There's a reason I use the normals. Don't question me. I know what I'm doing. I'm a professional. uh, did that instead of using the UV coordinates. Because these are icospheres, but you don't want icosphere UV coordinates for these textures. And I said, you know what? Screw it. Instead of doing instead of manipulating the UV space or replacing the geometry with UV spheres, I decided, you know what? We'll run with icospheres. We'll run with the icosphere, but give it in shaders. Use the normal to then create icosphere UVs procedurally. Because I'm insane. I don't know. Does that make sense? I think it makes sense. Because I like icosphere geometry. I hate how UV spheres all pinch towards the top and bottom. Anyway, that was just to give us time while this rendered, and I think that looks pretty darn good, man. I think that looks pretty darn good. Could use with a few more stars in the foreground. I should probably adjust the emission strength individually. Also, this is with no composite. Like we're using some compositing nodes, but I need to say as kind of a PSA, do what I say, not what I do. You should render EXRs and or not. You should render raw footage and like your layers separately so that you can composite them individually, so that then you can control things like individual emission strength and whatnot, or well, how much it shows up in the compositor with more finesse. That's the proper way to do it, but I just want to quickly give you guys something to look at. So it's this is not best practice, but it gets the job done, eh? Anyway, I think that's everything I had today. We could play with some animation, but it's been 2.5 hours and I need to go get some lunch. I am quite hungry. So thank you all so much for hanging out. If you're tuning in a little bit later, go ahead and check out the VOD and just, skip around. Feel free to copy this sort of workflow. This is not unique to me. I'm sharing this freely because I want to see more art in the world. So take this, modify this, iterate on it, make art. And I will see all of you in the next one. Thanks, bye.